How's it going? I've been helping people put permanent holiday LEDs on their house for about 4 years now. And the most common problem that I see people run into is flickering, or just general misbehavior. So let's go over the most common reasons for flickering and what you can do to make it stop. Ready? Go. Flickering is almost always a data signal problem. And data signal problems are almost always caused by a wire that's too long, too thin, or too close to other wires. It either happens between the controller and the first LED, or when you're splicing in extra wire to jump a gap between LEDs, like when you're jumping from one part of your roof to another. If you want some really good technical information about why data signals go wonky, Quindor wrote a great article about it. Because this problem comes up so frequently, I put together a flowchart. Let's go through it together. The first branch point is, are all of the LEDs flickering or just some of them? If it's all of them, then the next question is, how far away from the controller is your first pixel? And is the data wire bundled with the other wires? This problem may be solved by just physically separating the data wire from the positive and negative wires. If that's not possible, or if you try separating the wires and it still flickers, then the next easiest solution is to get a data booster. Another option is a sacrificial pixel. That's when you use an LED as a data booster. This isn't always guaranteed to work. Actually, none of this stuff is always guaranteed to work. If you want that sacrificial pixel to not light up, you can go to the WLED settings and click the Skip First Pixel box. I'm also going to say that you should always go through and check any connection points or splices to make sure they're all making a solid connection. If you're using a Node MCU, make sure the ground wires on the controller and the LEDs are connected together. If you're using a DigUno or Quad, the grounds are already connected on the PCB. Also, make sure you're using decent sized wire. 18 gauge or 20 gauge stranded wire is great. Using small gauge wire can cause a problem. And I've seen at least one case where someone used solid Romex type wire, and even though it was 14 gauge wire, it caused flickering that went away when he switched to 18 gauge stranded wire. Go figure. After some intense research, I discovered the problem. Gremlins. Inadequate power usually results in dimming and discoloration, but it can cause flickering too. So if you have a lot of pixels, like several hundred, then adding some power injection may fix the flickering. Also, try increasing the max current allowed setting in WLED. Less commonly, flickering may be a bad pixel, so the last thing to try would be to cut out the first misbehaving pixel and see if that fixes the flickering. Now the other branch of the deflickerizing map deals with some of the LEDs flickering, but not all of them. Almost always, when someone has this issue, it is occurring after they've jumped a gap. That is, they spliced in a length of wire to jump from one point on their roof to another. As long as that jump isn't too long, it's usually fine. But when that jump is longer than about 10 feet, you could get some misbehavior on the other side. The solutions are pretty much the same. Shorten the wire if possible, separate the data wire from the positive and negative wires, use 18 gauge or 20 gauge stranded wire or shielded wire, and double check that all your connections are solid. A data booster is also the easiest solution for this problem. You can place the data booster after the last pixel before you jump the gap, or somewhere in the middle of the gap. One unique solution that has worked for some is to splice in a pixel in the middle of the gap. And most likely, you've got plenty of extra pixels laying around, so it's worth a try. There is not an easy way in WLED to make that gap pixel not light up. So if you use a gap pixel, you can cover it with tape or paint, or a decorative stone carving of a gnome, if you have one handy. The most important thing about splicing in a pixel is making sure you get the orientation correct. All of these LEDs have an input side and an output side. Some make it clear which is which, but some don't. If there aren't any markings, then you can generally assume that the side with the biggest chip is the output side. There's no harm if you connect it backwards, it just won't work. If you get it wrong, just flip it around and try it again. Wiring up the data booster is pretty simple. 3 wires go in, 3 wires come out. Most likely, you'll want the little switch on the 33R setting. Quindor did design this board as an easy place to inject power as well. So I guess this is a good time to cover power injection. I'm sorry to keep covering the same things over and over again, but I still see people struggling with the concept of power injection, so I'm going to go over it again. Power injection is the solution to a problem. The problem it solves is voltage drop. Every LED adds a little resistance to the circuit. If you measure the voltage at several points down the line, you'll see it gradually decrease. There comes a point when the voltage drops so low that the LEDs will no longer function properly. The first sign is usually dimming, followed by discoloration, with the LEDs gradually turning more red. Then they may flicker, and eventually they just won't light up at all. Because the resistance that each LED adds varies with color and brightness, there's no way that I can give an exact point at which you will always need to inject power. I've tried to give some general tips about when you might need power injection, but the reality is you either need to connect up your lights and see when they start to dim, or just make a guess and add a power injection point where it makes the most sense for your setup. Against my better judgment, I'll give you my rule of thumb. If you're using 12-volt lights, then you'll probably want to inject power somewhere around 250 to 300 LEDs. If you're using 5-volt lights, then you'll probably want power injection around 150 LEDs. The reason 12 volts can go farther is because the LEDs actually expect 5 volts. So if you start at 12 volts, the voltage can decrease quite a bit before it gets low enough for the LEDs to dim. If you start with just 5 volts, it doesn't take very long before they start to dim. That's why 5-volt LEDs need more power injection points. That's a quick summary of the problem and the cause of the problem. So what's the solution? Voltage drop is the problem, and power injection is the solution. Power injection is simply running an extra pair of wires, one plus and one minus, from the power source directly to some point in the string of LEDs. The simplest thing to do is to run that pair of wires parallel to your LEDs and connect it to the far end of the string after the last LED, or to a point about in the middle of your LED string. When you get to the point where you want to inject power, you do a simple wire splice. You can use a fancy T-connector or a soldery melty connector, or just cut, strip, and screw the wires with wire nuts. It isn't required, but it probably is best practice to include a fuse on the positive wire of your power injection pair. If you're connecting directly to your power supply, you can use these inline fuses. They're certainly easy enough to splice in. If you're using a DIG quad, you can use the extra power output terminals, and that way the fuses will already be incorporated. The last question that often comes up about power injection is whether to run a home run from the power supply to each injection point, or just run one pair of wires and splice in at each injection point. For me, it comes down to the size of wire and the total current of your LEDs. If you have small wire and/or a lot of LEDs, which means a lot of current, then running a home run for each injection point is the best. But if you have a reasonable number of LEDs and you're using fairly big wire, like 18 gauge or bigger, then you can just run one pair and tap into the string of LEDs multiple times. When in doubt, just run home runs. It'll mean running a bit more wire, but it also means burning less brain power, worrying, or thinking about which way to do it. Well, that's it. That was my quick summary of fixing flickering and injecting power. I hope that was helpful to you. If you need help or want to talk to me or others, you can find us on Facebook and Discord. As always, thanks for watching. Till next time, adios.